Hi, everybody. This is Dolezal from the University of Illinois. I wanted to welcome you to my contribution to this year's online version of the Illinois State Beekeepers Association summer meeting. I want to thank the organizers of the meeting, especially for coming up with a way for us to still have these types of presentations in an online venue, even though we can't meet in person. I'm really looking forward to a chance to meet in person again, but in the meantime, I'm hoping this series of short videos that I produced with my lab will be interesting and informative and give you some picture of the kind of bee research that we do here at the University of Illinois. Thanks for your attention, and I look forward to seeing everybody happy, healthy, and safe in the future. Hi, I'm Dolezal. I'm a professor in the Department of Entomology at the University of Illinois, and my lab does a lot of its work here at the UIUC Bee Research Facility. And we were supposed to have our beekeeping short course this year, but of course that, like lots of other things, was canceled. And so I wanted to take this opportunity to give people a virtual tour of our facility and go through some of the different types of things that we do in my lab. So this facility has been here a little over 10 years. It's relatively new. It's the second bee lab that the University of Illinois has had in the last 30 years. And I don't occupy this alone. This is a lab space that is used by several different University of Illinois bee researchers. It was here before I came, and I'm really excited to get a chance to show it off because it's one of the world's best bee research facilities. And so we have a lot of great resources here to investigate lots of different parts of bee biology. And some of the work that goes on here is really basic biology, understanding how hormones affect behavior and how genes work to build the behaviors and the body types that we see in bees. And they can also be used as a model for some human diseases and disorders. But most of what my lab does is look at honeybee stresses. So we've spent a lot of time looking at honeybee pathogen infection, mostly using viruses like Israeli acute paralysis virus and the foaming virus. We have projects looking at pesticide exposure, particularly those pesticides that are used in Midwestern agricultural systems like corn and soybean production agriculture. And so we have some projects looking at those. And we also do work on bee nutrition, again, focused on the nutritional qualities that we observe here in the Midwest. And how different landscapes and different landscape features like road edges or field edges, prairie restorations, how those things can contribute to the nutrition that honeybees get, and really what is the most efficient way to improve their nutrition in these landscapes. We also spend a lot of time trying to look at these factors together and see how they interact. As you can hear, there's some cars driving by. This is a busy facility, even on the restricted timelines that we have this year. We've got assistant researchers coming here to the bee lab, pulling in on the road right behind us to come in and start doing some of the lab work that we do here at the facility. And so today, instead of giving a kind of boring me sitting at my desk and just talking with PowerPoint slides, I'm going to walk through some of the facilities we have. We're going to see some talk by our bee lab manager, Nathan Beach, who is the one who really keeps all the bees healthy and happy and available for us to do experiments. We're also going to have some short videos by some of the students and post-doctoral researchers who work in my lab. We're going to talk about the types of experiments they do and how we set them up. A lot of what we do is really beekeeping oriented and we work in the field, but we also spend a lot of time in lab situations, rearing bees under controlled conditions and doing experiments with them. And so these are things that most beekeepers will not have seen before because we are doing things in a kind of artificial way to really control a lot of the factors that bees could be exposed to. And so we'll get to see some of that as well. We'll also take a look at some of our outdoor resources, which, as you see when you come in the main road of the Bee Lab, you see our main building, our garage, we store a lot of equipment. But then out behind it, you'll see we have several large greenhouse-type buildings where we can do enclosure experiments, where bees can freely fly, but they can only live within that small greenhouse and forage on what we want them to forage on and be exposed to things that we want to expose them to. It also allows us to expose bees to pathogens and see what happens without releasing them into the wider world, which would be really irresponsible. So, like I said, this would be a little bit different. It's a little bit different for me than a lot of the other types of presentations that I've ever given. I hope it's interesting. I hope it's a little bit of my excitement for this work rubs off. And hopefully there's a little bit of something for everybody who hasn't seen this kind of thing.
So one of the capabilities that we've built here at the Bee Lab is the ability to run observation hives in multiple capacities. And one of those applications is running the observation hives with a camera and computer system that can track individually barcoded bees and track their foraging and their activity inside the hive as well as outside the hive. And that's the purpose of these sheds behind me. These sheds were built last year for a specific project in the lab where we want to control the environment of not only the observation hives, but also of the bees' forage. Previously, our research has allowed bees to forage freely, and so they are foraging on whatever pollen and nectar is out in nature. But with these what we call bee domes, these netted hoop houses, allow us to restrict the bees' forage just to what we provide inside of the net. And so each of these domes is split in half, so that gives us 4 compartments that we can run 4 individual hives. And then the observation hives are single-frame glass-walled hives that have about 1,200 bees, and so it's a very small colony, and because of that, they have trouble thermoregulating their environment. And so we build these sheds which are fully insulated and also completely environmentally controlled. It's pitch black inside. We have air conditioning, humidity control, heat, air movement, and also dehumidifying ability so that the environment inside the shed will remain stable no matter what the exterior environment is. That helps us keep a tight control of the environment of the hive itself, and then we can also control the resources that the bees have access to through the domes. We will feed the bees a diet of ground pollen and sugar water, and we can change the composition of the diet as well as add different additives depending on what we want to test. And we can run 4 colonies at a time, and so we can have 2 treatment groups and 2 control groups, and then we run them for about 2 weeks, and then afterwards we can analyze the behavior of the bees from inside the hive. Our capabilities include a camera trained on the observation hive itself inside. It uses infrared light, so it's not visible, and so it maintains the darkness of the sheds. And then there's also a camera on the outside of the hive at the entrance where we can record bees coming in and out of the hive. And last year we added the capability to actually record bees who are feeding on the sugar water. So we can tell exactly who is foraging on the sugar water, how long they spend foraging on the sugar water, and when they return to the hive, and who they pass that sugar water onto for it to finally get stored in the cells of the hive.
And here we can see what the inside of one of these colonies might look like. Each bee has one of these barcode tags glued to her back. This tells a computer where the head of the bee is, where the abdomen of the bee is, and also encodes individual information. So we can track where every bee in the colony is, how much it moves, when it forages, when it returns, how much they interact with the queen. And we can also track specific behaviors like trophallaxis, that food sharing behavior that we can see the bees that are on screen now engaging in right now. And we use this technology in a recent study where we found that when bees have their immune system turned on against viruses or are infected with Israeli acute paralysis virus, that they reduce these types of behaviors. We think in a social immune response that helps prevent pathogen spread throughout the colony. And so this is a pretty amazing tool for observing bee behavior that we have the ability to use here. And we'll talk a little bit more about how these barcode colonies are made a little bit later.
This small structure behind me we have dubbed Waggle World because it was built specifically to set up an array of observation hives that researchers would then be able to sit inside and do manual observations of the bees. So this was one of the earliest structures for observation hives that we built here at the Bee Lab. You notice the 3 ports on the side of the building. There are 3 ports on each of the 4 sides of the building, and it allows us to set up the observation hives to observe the bees. Since then, we have gone on to using cameras, and the cameras allow us to observe bees 24/7 and then be able to analyze the specific areas that we want to, versus being restricted by having human observers and picking the optimal times for observations. So we've really been able to expand our capabilities with other structures that we've built here at the Bee Lab. All right, so this is the construction site of the newest building here at the Bee Lab. This building is being funded by a grant from the University of Illinois Student Sustainability Committee. This grant was secured by the former Bee Lab manager, Allison Sankey, and it's a dual-purpose building. So this structure will, during the summer months, during the field season, we'll be able to have 8 observation hives with the full camera rigs in this structure, and we'll be able to run experiments, free-flying bees, free-flying experiments with the observation hives here. During the winter, though, something that we're excited to start looking into more, we will be able to move full-size colonies from the field into this structure and practice some indoor overwintering. And so this building, again, right now, it's just a foundation, but in a few days, we will have a full structure. It will be fully insulated. We will have complete environmental control inside, so light control, air conditioning, heat, humidity, all of that will be tightly controlled, and this will provide a stable environment for colonies that we move inside for indoors over the winter. So the importance and the idea behind indoor overwintering is that, as we know as beekeepers, winter is the hardest season for colonies, and especially with the changing climate environment that we've experienced, we see drastic swings between warm days where bees might be able to fly to freezing days the next day. And this is very harsh on our colonies. It kills bees and it can cause a lot of problems. So one idea that's been proposed and is being practiced by commercial beekeepers throughout the United States is moving colonies into an environment where the environment is held stable. So the temperature is kept just low enough so that the bees don't need to leave or fly, but it's not so cold that it will kill bees. So the idea is that we keep a constant, stable environment where the bees don't suffer from the wind or the temperature fluctuations of the outside environment. So our goal here at the University of Illinois is to do just that, provide a constant environment and reduce our overwintering losses. Now, there are a few things to take note that research has pointed to and experience from commercial beekeepers who've already done that. One of which is to make sure that the colonies going inside are already healthy. If they're weak or full of mites or viruses, then you kind of get out what you put in. So if the colonies are too weak or sick, they're not going to come out in spring very strong. But if you put healthy colonies inside with enough food resources and enough bees, they can come out without having suffered the ups and downs of the weather that we experience here in central Illinois. One of the main reasons that we are taking on this project here at the university is not just for the health of our own colonies, which is vital for the research that we do, but also to further explore the dynamics of overwintering in honeybee colonies. This is an active area of research that, quite frankly, we don't know a whole lot about. And so we're excited to be able to run studies where we can compare colonies kept here in a very high-tech, highly controlled environment, as well, and compare those to colonies kept outside in our apiaries, as well as some other structures that we have here that aren't as tightly controlled, but still but still are insulated and provide protection from the wind and kind of mitigate the temperature fluctuations that we experience in the outside environment. So we're very excited about this project and hoping to get started on some research this winter.